So in this next section that we're going to look at, we're going to be talking about trying to create an equation from a given graph. So let's say we have this graph right here. And we say, okay, so apparently we have our vertex, which is also our line of symmetry. We have our rightmost point, and we have our leftmost point. So with this information alone, we can actually give a lot of other information from it and create our equation. So essential parts to note is one, obviously, is our vertex, which is going to have our h and our k embedded into it. And the other thing to note is going to be the slope that it took to go from our vertex to our rightmost point. And so what we'll also see is that our rightmost point and our vertex together hide the slope. Because you can ask yourself, well, what did you have to do to 2 to get 5? And so 2 plus what is 5? Well, 2 plus 3. And that is our run, okay, which also becomes our b. Our rightmost point here of 3 and our k are also related. Because you say, what did you have to add? This quantity here is whatever k plus a was. And so 1 plus what is 3? Well, 2. So we can actually get the values of our a, our b, our h, and our k all right here. And just like that, I have the information to plug into my equation. A, absolute values, 1 over b, parentheses, x minus h, which is a positive value, so it's minus, absolute value plus k. So let's see what other information we can also get from this regarding our graphs. So our rightmost point, just to reiterate that, is a composite of h and b put together. So when you put the h and the b together, you get this rightmost point, the x value of the rightmost point. When you take the a and the k and put them together, you get the y value of the rightmost point. So it's a very interesting connection to make of how you could use this and this to find your a and your b, or vice versa. How you can add your a to your h, and your a to your k to get this number here, and your h to your b to get this number here. So let's see what other information we can also get from this. We obviously know what our vertex is, because, well, that's this point here. As long as you know that's what the definition of vertex is, it's the center part of that v, or in parentheses, parabola, it'd be the low or the high point, or point of transition. That's going to be our vertex. Our line of symmetry is going to be the same. But we're also going to be kind of revisiting the concept of our domain and range. And here you do see that I worked out the math to be able to check your answers, that you do have the right quantities, that the rightmost point was 5, 3. Well, h was 2, b was 3, so together those make 5, which gets me my correct value here. And my a was 2, my k was 1, which gives me my 3, which matches the points here on my rightmost quantity. So kind of a neat concept to pay attention to on that one. With our domain and our range, from a lot of these type of basic problems where it kind of goes forever infinitely negative x values and infinitely positive x values, our range is going to be just that. All real numbers basically for x. X is greater than all negative infinite numbers and less than all positive infinite numbers. Basically all real numbers. Range, though, does something a little different. It actually is going to be connected to your k, because the k indicates your rise or fall, and that's basically the same thing as your y. So if your k of your vertex is 1 and that then has points above 1, then your range, which indicates your y, is going to be, oops, and I think I actually got this one flipped. Make sure I get that right. Make clear on that mistake up. Y is going to be greater than or equal to 1. So it just kind of depends. Obviously, if this is a positive graph, then y is going to be greater than k. If it's a negative graph and it's going down, then y is going to be less than k. So it just kind of depends on the situation. For here, it's going to be in relationship of being greater than k because your a is a positive. Okay? So let's apply this concept onto another looking graph. So again, we have this information here. We have our vertex. We have our rightmost point. Our vertex is also our line of symmetry. This is going to be my h. This is going to be my k. I'm going to ask myself to find my a and to find my b as to what did I do here to go from -2 to -3? What did I do here to go from 3 to 6? And so what you'll get is your quantities of a is -1, b is 3, h is 3, k is -2. That's what you get from your vertex. Here thus becomes your slope. To go from here to your rightmost point, you're going to go down 1 and over 3. So that's your a over your b, which allows me then to create my equation. Also from here, I can start doing my domain and my range. My domain doesn't change because, again, all x values are going to be on the table, you can say. I can pick any value of x and it's part of this graph. My range, though, is connected to my k, which is the -2. And since it's a negative graph, it's going down all values of y below or equal to 2, so y is less than or equal to -2. So last but not least, last example to kind of how to be able to create an equation based off of a graph. Vertex, rightmost point. You can figure out your a and your b. Try those. Note that your h is a -4. Had a left horizontal shift to the left. So we plot our basics. Rise of 3 over by 2. H is -4, k is 2. So there's my vertex, my rightmost point, doing the math for that information there. And thus my equation AB. This is a positive 4 because remember the equation is x minus h. H is a negative 4. So a negative times a negative becomes a positive in our equation. K is plus 2. So now we are able to create our equation based off of just getting our values from the points in the graph. Domain, all real numbers again, that doesn't change. Range is in direct relationship to our K. So it's all points greater than or equal to 2. So there you go, some fundamental basic information of how you can create an equation just by given points related to and the graph of certain functions. All right, I hope this helped.